So Helen is the Director of Construction, Work Health and Safety at RMIT in Melbourne. Helen has presented for the Better Work TAS program on a number of occasions, covering all sort of topic areas. So today she will speak about crane safety, and we'll just let Helen get ready with that. Thank you very much.
Great, thank you very much. Can everybody hear me? That's all good? Yeah. Okay, so today I want to talk about a piece of research that we finished late last year. It was funded by the New South Wales Government Centre for Work Health and Safety, and this project looked at crane safety in the Australian construction industry. Now, look, just a bit of background information. This is data from Safe Work Australia. In Australia, there were 47 workers killed in incidents involving cranes between 2003 and 2015. And there are around 240 serious injury claims arising from crane-related incidents every year. So there's this sort of residual issue around the safe use of cranes and lifting operations that Safe Work New South Wales wanted to understand a little bit better. So the research project had a couple of aims. First was to identify the causes, or at least the contributing factors, associated with the safety incidents that involve cranes in the construction industry. So this work was specific to construction. And second, to identify strategies that could potentially be used to reduce the risk of crane-related incidents. So the scope was really about the construction industry, and also specifically around fixed and mobile cranes, so tower cranes and mobile cranes. The primary data collection was undertaken in New South Wales, reflecting the fact that the work was funded by the New South Wales Government. However, notwithstanding that, we did do one focus group involving regulators from across all the jurisdictions in Australia. So we looked nationally at the regulators' perspectives. The component parts of the study were a big literature review of international work on crane safety, and there's a fair amount actually, which was good to be able to access to look at what's known about crane safety incidents in the US, in Europe, in Asia, and other places. And then we did some focus groups. We got industry experts and representative groups, including organisations like the Crane Industry Council of Australia, regulators, the Master Builders Association, major contractors and crane operators. And we got them all in these focus groups where we asked them about what they thought caused crane safety incidents and what needed to be done to prevent them. We analysed all of that data. Then we actually did some further validation and case study analysis, which I'll describe in a little moment. But just some New South Wales data, because the part of the project involved looking at the Workplace Services Management Systems database in New South Wales from 2002 to 2019. And in that database, we were able to identify 1,461 incidents which contained the word crane. And these were filtered down further to be 72 incidents that resulted in a fatality, 605 that resulted in serious injury, and 799 that were recorded as dangerous incidents. So we actually were able to take that bunch of data. I have to say that this portion of the analysis, the statistical analysis, was in fact done by two colleagues at Safe Work New South Wales. So we worked collaboratively with them and jointly published the report. So this New South Wales data was looked at quite closely, and you'll see that particularly between about 2015 and 2018, there's quite a substantial increase in the number of crane safety incidents. And again, we don't really know why this is the case. It could be more incidents being reported. It could actually be more crane-related activity in the construction industry during this time, or it could be something else going on in terms of increasing incidents related to cranes in the construction industry. You'll see that increase was particularly sharp there for tower crane incidents, which is the graph on the top left-hand corner of that particular graph. The other information that we looked at was the type of incidents that occurred. And you see at the top here that shows all the mechanism of incident for all cranes, but below that there's mobile cranes and tower cranes separated out. You'll see hit by load is frequently occurring for both mobile and tower cranes. Hit by the crane itself is much more prevalent in tower cranes relative to mobile cranes, and crane collapse is much more prevalent in mobile cranes. So you can see sort of a profile difference in the mechanisms of incidents associated with those two different crane types. The other thing about this data was we looked at the causal attributions to these crane safety incidents, and the graph here shows us, it shows that incidents that were attributed to human error, which is the sort of pale blue section in these graphs, actually increased from 72% in 2016 to 89% in 2018. And incidents attributed to faulty equipment actually decreased in the same period from 21% to 11%. So it seems that human error is increasing as a causal factor, faulty equipment is decreasing. The other interesting piece of information that came out of this analysis of historical data was that the research team was able to cross-reference the incident data with the high-risk work license database. And so we were able to look at the characteristics of workers who were involved in crane safety incidents. And you'll see that these graphs here that show riggers, dogmen, and licensed crane operators from top to bottom, respectively. The grey areas in these graphs actually that represents the experience profile of the people involved in incidents, and the coloured, the green, yellow, and blue areas in the graph actually shows the experience profile of all people who hold a high-risk work licence for that particular activity. So what you'll see here is that experience really matters, because you can see quite clearly that people with 10 years experience or less are much more likely to be involved in a safety incident. And in fact, 5 years was very statistically significant. So people involved in crane safety incidents tended to be less experienced, particularly 5 years or less, and that finding was statistically significant. So this tells us that experience is actually really important. Just going on to the literature, we did a huge literature review, and the reports are online, and you can download it freely online, and it's quite a substantial report. So by all means, if you're interested in looking at this in more detail, you'll be able to find all this information. I'll just briefly summarise my observations of the literature. The first thing we noted was that there's actually a lack of a consistent approach to data analysis. So depending on which study you look at, where in the world it was done, you'll find different analytical approaches, different causal frameworks used. Makes it very hard to compare apples with apples. It makes it very difficult, for example, to compare one study that's been done in the UK with a study that might have been done in the US, because they classify incident types and causes quite differently usually. The other thing that's often observed is that the type of incident, whether a crane's overturned, whether a crane's come into contact with overhead power lines, whether there's been some structural failure, those types of incident are often reported as the causes, when in fact they're probably not the causes. What really needs to be understood, I guess, is what caused the crane to overturn, or what caused the crane to come into contact with overhead power lines. And that really in-depth causal analysis is often missing. So that was the other observation. There's a really heavy emphasis as well in the literature on human error as a cause, and this includes human error relating to the operation of a crane, as well as to substandard rigging and lifting practices. But there are some incidents where there is evidence that there was no immediate behavioural cause, and in fact the incident was attributed to design or technical issues. Now those incidents were quite rare, but they tended to be quite catastrophic. So again, there is evidence that latent condition pathways are relevant to crane safety incidents in some circumstances. And then more recently, what we're starting to see is the adoption of a systems approach to understanding crane safety incidents. And what I mean by that is, rather than just attributing them to human error or to a failure of a component, there's actually an attempt to try and look upstream at organisational or managerial factors that might have contributed to that error. It might be poor training, it might be poor maintenance, it could be a whole range of factors, work pressure, project timelines, and so on. So there is this growing recognition that some of those organizational or managerial factors are relevant. And one particular study from the UK actually did look at this in some detail and identified things like time pressures and tight deadlines, encouraging unqualified workers to do things related to cranes that they probably shouldn't have done because they weren't trained to do them. And so that was one cause. They looked at construction contractors, often believing that contract lift hiring would mean that they didn't have responsibility for the safety of crane operations. Too much emphasis on paperwork, need for more rigorous processes for planning lifting operations, and then issues around training for lift supervisors, slingers and signallers. So these were all identified as managerial or organisational factors in the UK construction industry that people believed contributed to crane safety incidents. So we looked at that literature, and we looked at the data from New South Wales, and that gave us a sense of what in other areas that there appeared to be issues around crane safety. But we wanted to know really what was going on in the Australian context. So we did, I think, eight focus groups and a bunch of interviews as well. And from that data, we ended up with, I think, 444 pages of transcripts. So a lot of information, a lot of people told us things, and there was a lot of very rich and useful data collected. That data was then systematically analysed over a very long period of time. It was quite a lot of work to sift through all of that data. But what we did with it was we developed these cause-effect trees for 5 broad areas: work environment issues, work site conditions, human factors, equipment issues, and task activity issues. And this is just like one little snippet of one of these cause-effect trees. They were actually quite large and got quite complex, but it shows in relation to an operator not following the crane manufacturer's instructions, the things that we could identify as causing that. So on the left of this diagram is closer to the incident, and on the further right you get, the more distant it is from the incident. But you'll see that the operator not following the manufacturer's instructions was explained by sometimes them being unfamiliar with the plant they were using, competence issues that were associated with problems associated with verification of competency issues, inadequate onboarding, particularly for new to industry or migrant workers. That came out quite strongly. An increase in those new to industry workers, which was driven by resource shortages, and ultimately right back to the fact that the construction procurement environment at the time was overheated, and there was a shortage of skilled workers to actually to engage with cranes and lifting operations. So you can see how we trace back those immediate causes back to more systemic factors associated with the way work is planned and managed, and also characteristics of the industry. So the crane safety incident causation model that we actually developed as a result of this work actually collated all of those causal or contributing factors that came out of the analysis. And you'll see that we've arranged this at 3 different levels. In the middle of the diagram is the factors that were immediate incident circumstances, the immediate things closest to the incident. And they were grouped as site factors like changes to ground conditions, lighting and visibility, that kind of thing. Material equipment factors, perhaps a crane was too small for the task being performed, maybe the load transfer was too far. And worker factors, people taking shortcuts, lack of hazard awareness, not following instructions and so on. So you'll see those immediate circumstances, but we then trace those back to, at the next level of the diagram, shaping factors. And again, shaping factors were grouped according to worker factors, job factors, management factors, and they were sort of the things that contributed to these more immediate circumstances. And again, it relates to things like working hours and fatigue and mental health, obviously a topic that's been discussed today as well. The transient workforce, overcommitment of crane companies in the heated construction environment, site constraints, poor coordination or oversight of documentation and planning across multiple contractors. So there's a whole range of things in there. And these all came from the data. We haven't made any of these up. These are all from our industry experts and the people who we consulted with in those focus groups. Now, beyond those shaping factors, there's an even more distal, if you like, group of factors which we've called originating influences. And they relate broadly to things that are going on in the industry context. The client's demands and expectations, regulatory issues around permit conditions, the consistency with which RTOs deliver training, and these sorts of things. So these originating influences or procurement methodologies was actually a really big one, whether it's a crane companies engaged or whether a crane's brought on site in a dry hire or a wet hire type arrangement. These were things which came out as the originating influences that would actually impact on crane safety incidents. What we think this model is useful as is it could be used in two ways. It could be used first to help companies to understand crane safety incidents. So if you have a crane safety incident in your organization, you could use this model to sort of look at, well, what were the factors? And you could ask yourself whether any of these factors were at play. It doesn't mean that they're all going to be relevant in every circumstances. It doesn't mean that that you'll be able to necessarily trace things back to originating influences in all cases. But the model is quite useful in the sense of understanding how and why incidents have occurred. But the other use that we see it having is it's actually, we feel it's potentially very useful as a proactive planning tool. So if you're going to have cranes and have cranes on your site, which, let's face it, most construction projects use cranes, then you could actually use this to say, well, what are some of the things that could in fact cause a problem, and do we need to consider, for example, the crane contractor's knowledge and experience, the communication that takes place between the principal contractor and the crane company before the work commences, and these sorts of things. Do we need to look at some of the RTO performance and the training of the workers or the aging fleet? So you could kind of use it there as a proactive tool to sort of plan and preempt and try and prevent things from going wrong. What we did with that model was that we took it back to a smaller number of industry experts, and we gave them case study crane safety incidents that were real life incidents that we could find information about. This was one case that occurred in New York in 2008, and we were able to document what happened in this incident. We then went back to the industry experts and we said, could you use our model to actually map what went wrong in this particular case study? And what we found was that when the experts used our model, they produced a much higher level of consistency in the factors that they identified. And we also found that they were able to use the model effectively for both tower cranes and mobile cranes. So it gave us some confidence, that validation that the model was actually useful in terms of getting people to think about and classify causal factors in a sensible way. And the diagram here on the right is just one of the outcomes of that validation process. This is what one of the experts identified in that case study using the model as being the things that went wrong. So we felt that was actually quite useful, and certainly the people who we engaged in that validation were all very positive about the model and all sort of said that they would actually find it useful and they would in fact use it in practice. The suggestions for prevention, so we had two main aims. The first was to look at what were the contributing factors to crane safety incidents. The second was to look at suggestions for prevention. And there were a lot of suggestions made, which we broadly grouped into these categories. And again, each of these is unpacked and described in much more detail in the report. The industry people who participated in the work felt strongly that they wanted a specific code of practice for crane operations, that would be useful. They didn't think, obviously, there was enough guidance and material specific to cranes and lifting operations. The role of the regulator came up a fair bit. That was mainly around wanting more proactive inspections that were unannounced, as well as more mentoring and guidance around crane safety. There were suggestions made about design and import issues, having better controls around design and import, and then the use of technology. So things like using technologies like lift planning, which is linked to building information models, 3D visualization of lifts linked to CAD models, the use of anti-collision systems, GPS positioning, and data loggers were one of the things that came up as well, being able to use a data logger to record crane usage. And these are in fact mandated in Singapore. So a lot of the recommendations were in fact around a lot of the recommendations were around training and competence, and these again, worth exploring a little bit more. A lot of the participants said that a lot of crane accidents have happened in the last 4 to 5 years because there's so much work on, and crane companies are just struggling for guys, was what they said. They commented on somebody, for example, could be flipping hamburgers for 15 years, and then they can do a relatively short course if they're conscientious enough. They can then find themselves operating a crane with relatively little experience. So there was a real concern around that level of experience in the crane workforce, and indeed that the ease with which workers could get high-risk work licenses and actually enter the industry to do this kind of work. So one of the suggestions, was a tiered licensing system where people might be recognised as relatively inexperienced through having L plates and P plates was one of the suggestions that were made. Having a logbook and recording experience and making sure that experience was recorded, so you knew when you engaged somebody how much experience they had and it was documented. Some periodic testing and assessment. And there was also strong suggestions that the verification of competency requirements should in fact take heed of the crane type, make or model. And the Crane Industry Council of Australia system called CrewSafe was one way of actually being able to achieve that. That was heavily favoured by the people who participated. And interesting enough, there was also a strong recommendation made that there should be specific training for workers whose activities could impact on crane safety. So, for example, site engineers or people who are engaged in coordinating lifting operations. So not necessarily the operators of the cranes, the riggers or the dogmen, but the site engineers who are engaged in actually planning for cranes and lifting in the construction industry. And there were a number of comments made about the fact that, just because you were a good engineer, it didn't mean that you necessarily understood crane safety as well as could be expected. So that's really the research. That's the findings, very, very briefly put, because it's quite a substantial report, which by all means you're welcome to download from this website here. Just to acknowledge the work was funded by the New South Wales Government Centre for Work Health and Safety, and Safe Work New South Wales also oversaw the work, reviewed the research and approved the publication of the reports. And I'd just also like to acknowledge that the work was a real team effort, so it wasn't done entirely by me. There was a large team of people working on this in various parts and roles. So thank you. If anyone has any questions, by all means, feel free to ask.
Going back 7 years, I was a training manager up on one of the mine sites in West Australia, and we used to get people come up there. They'd get a rigger's ticket, come up there to be a rigger or an advanced rigger, and we had a high-risk licence assessor on site, as well as the crane supervisor, and you go out with the content experts to see if these fellows could do what they say they could do. Half of them couldn't even tie a knot on a tagline. and then they wonder why they're getting demoted to work around a franner until we could trust them. And it was the same with the crane operators, the same deal, and obviously it's getting no better. It's like the crane operators at the moment seem to be getting the tickets too easy, and they've lost the sensible approach before they operate the machine. And the same with the different machines, the cranes. We'd have operators get out of one crane, get in another crane, have no idea how to operate because the controls are all different. And yet they had a ticket. But it's not crane specific. And we had 3 superlift cranes there, we had 50 oil cans hydraulic cranes and 35 franners of different sizes. So we had a fair selection. And we used to turn over our crane drivers as if they were going out of fashion, try and get decent ones. So it's obviously it's not improving.
Any comments there, Helen?
Oh, look, I hear what you're saying, and certainly I think of all of the recommendations and all of the factors that came out the most strongly. That was the biggest issue, and you know, it was a real concern for all the experts and industry participants we spoke to. So certainly, I think that it appears to be a really big issue that needs to be looked at.
Is the fact that we're having more accidents due to the cranes becoming larger and the dogmen and riggers not, or the crane driver not being able to see where the load is going?
That's an interesting question, and it's not something that came out of the data to my knowledge. I don't think anybody raised that as a specific causal factor. But again, it's the model that we've developed was based upon what people told us. And the way that we've described it in the report is that it's actually really just a starting point. It's not necessarily comprehensive because we did 8 focus groups and some interviews. And while we ended up with a lot of data, I can't guarantee that every single factor that is relevant was captured in that model. So one of the things that we've suggested in the report is that the model is treated as a living document and organisations continue to add to it as more information comes to light. So it would be very interesting to actually look at real case study incidents and try and gauge whether what you've just described is in fact a factor. All I can say is it didn't come out of the things that people told us in the workshops, but it doesn't mean that isn't a factor. And without actually looking at detailed analysis of cases, of specific cases, I'm not able to tell you whether that's a factor or not, but it would be an interesting thing to explore.
Thank you. Yeah, just a couple of quick comments. One with regards to the training that was raised before. I have actually, we have a crane hire company here in Hobart, but I've actually come across somebody that did come over from, well, it was from Western Australia, but it could have been from anywhere, where those quick 1-week training courses seem to come out with somebody who has is a fully qualified rigger and got an open ticket with a crane as well, and he was a danger. We ended up we persevered with him for probably a month or 2, but he had to keep getting told what to do repetitively, and he just wasn't suitable for the industry, but he did have a ticket. So that was the real problem. And I had a word to him and I said, listen, I said, mate, I said, I just can't, I can't take the risk. So we ended up letting him go. I felt bad about doing it, but I've got a duty of care to the people that work on our sites and to our own people, as well as the other people that are surrounding where the crane is. So that's quite a valid comment from that perspective. And the other point with regards to the question of is it because the cranes are getting bigger and it's out of sight, there are ways to mitigate that, and one is radios. Sometimes the two-way radio the battery may go flat, but if you have another person in a third spot there who is in line of sight of both the operator and the rigger that's out of sight, then you can transfer the signals through, and you still can have whistles and whistle signals to make sure the operator stops.
Any thoughts?
And just to add to that, one of the things that the literature review revealed is some technologies that can also assist with that 3D visualization and positioning of loads when there isn't a line of sight. Now, some of those technologies are being used overseas to varying degrees. Some are still sort of under development, but there is, I think, a role for advanced technologies to be deployed as well in some of these areas, from what we can gather from the literature and the emerging evidence.
What you're finding now, though, with the bigger cranes, the lifts are becoming easier because the cranes are better suited to the lifts. The big thing now is doing the research on where the crane pads go and what the ground conditions are like for the crane company when they get there, to take all the judgment away that the ground is suitable for the actual crane pads. I know when we put the big Brooker Bridge up, we had to get the council in to find out what services are under the ground there, because there's an underground creek there. We had to put pads there. That's why the nature strip was all dug up, to get the compaction right for the pads. If your research is done right, and we've got about a 6-page form we've got to go through, get engineers sign off, management sign off, then the crane company come in with their lift studies and weigh up the outriggers. You shouldn't have these accidents. If they're done properly and it's planned out properly, they should be right. It's just, I think some people are getting their tickets too quick, and there's not enough thought going into the actual lifting. The other big thing we got wasn't brought up in there. I work for a bridge building company. Yes, we lift bridges with excavators. We brought 2 brand new excavators. We fitted them up with crane lift gear, crane scales, everything on them to lift them up. Where does that come into your statistics in New South Wales? Because an excavator is used as a crane. Now, is that in your statistics or not?
No, it wouldn't be. I doubt very much whether it would be. And the reason I say that is that it surprised me a little bit that when they went to that database to try and identify incidents involving cranes, they used a keyword search. So they looked for the word crane in either the description of the incident that was in the database or in the recommendations that were made by an inspector who visited the site. So the word crane was actually in there, which is how we were able to identify those particular incidents as being crane related. So they weren't lifting related, they actually had to have the word crane in them. So unless an incident was misclassified and they used the word crane instead of the word excavator because it was a lifting activity, I don't think they would have been included in that particular data set. But your point is very valid in the sense that that's a whole different category of incidents that or potential issues that need to be looked at and understood. Certainly our data set, I don't think would have captured those things. But going back to the previous point as well that was made about the need to have a detailed site investigation, understand the context, the ground conditions, any restrictions around adjacent buildings or infrastructure, and do that early on so that work can be planned properly from the very start. That came out as a really important factor in the analysis. And in fact, particularly in the use of mobile cranes, quite a lot of the people who participated commented that often you get a call the day before to come and do some lifting the next day, and there's very little time for planning and thinking through how to do that work safely. And potentially worse than that, when the crane goes to site, it was also raised that often people will say, oh, while you're here, can you do this? Could you do that? So the nature of the job actually changes even once the crane arrives on site. So this communication challenges and the lack of time spent on planning, and particularly the principal contractor, engaging the crane contractor with sufficient time to really do that planning, was actually one of the areas of concern. And related to that was also the commercial arrangements within which principal contractors engage the crane companies, because one of the things that the crane companies told us was that they would actually like to have some standard documentation in that commercial contracting process that clearly laid out safe working parameters. So when the safe working parameters were not applicable, they were well within their rights, and it was very clear for them to say, no, we're not actually going to do that today for these reasons. So again, that documentation and the way that the relationship works between the principal contractor and the crane company was actually one of the big things that came out as being something that needs to be looked at potentially.
When you were doing your research, the quality of the data that you found available to do your analysis and stuff, how did you find that? And if you were to make a recommendation to businesses in the sort of hit points that they could be recording out of their incidents to get some of this same sort of analysis and stuff, what would it be?
Well, I think one of the things that going back to 2015, I actually did an analysis back then of fatal crane safety incidents using the National Coronial Database System, information system, which is coronial findings from all around Australia, and we were able to use those coronial findings to identify incidents involving cranes and then try and look at the causal factors. And it was really interesting to me that even in those very serious incidents that had resulted in some coronial investigation, often the data was not so detailed. And I think one of the problems is that depending on who records these incidents, depending on how they're reported and who ends up recording the incidents, they're not necessarily capturing the really useful information or the insights. So if somebody's recording the incident who doesn't really understand the construction industry context, they might not record things in a way that really captures good information for prevention purposes. And certainly, I think it's fair to say that there were limitations, certainly in the historical data that we were able to access this time. And what I would suggest is that maybe a model like the causal model that we've identified could in fact be a useful way to try and classify information in a more systematic way, so that you get more consistency in what gets recorded and perhaps a bit more detail as well as to what were the contributing factors. Now, obviously, the further away those contributing factors are from the incident, the harder they are to identify and the less direct the relationship is. So you've got to be quite careful capturing that data, how you then use it and what you would then do with it. But I still think a framework like the model that we developed, if used to capture and code data, would produce richer, more useful data for prevention purposes.
Any other thoughts, comments? Well, thank you very much, Helen, yet again, for a raft of information. We can always rely on you for that. Very thorough, comprehensive research there, and I think it gives us great insight to the hard work that your research team does. So thank you very much, Helen.
Thank you very much. It's my pleasure.